series in soft computing for computer science. In this lecture, what we are going to see is how a MATLAB code is developed for a backpropagation neural network. Further, this presentation will discuss about how a data classification model has been implemented. So, the overview of the presentation are how the MATLAB software is used for loading the data set. Once the data set is loaded, how the loaded data set has been separated into training and testing. After that, how a neural network model architecture is defined in terms of input layers, output layers, hidden layers, like that and all. Followed by that, how the values of weights and bias are assigned. So, after having done all these things, how the network is initialized. Once the initialized network has been created, how training as well as testing has been performed in order to simulate the model as well as to receive the result. So, let me go one by one. See, this presentation will give you the various MATLAB code and how this MATLAB code is helpful in implementing the backpropagation neural network model. As I said in my earlier presentation, I start with CLC as the first MATLAB statement in order to clear the console, because in the MATLAB development environment we have so many windows and we have so many variables that have been created in the workspace as well as in the command prompt. So, we have to clear all the console first. So, the first command CLC is meant for clearing all the console values. Then clear all. So, is there any default values with respect to the variables are available, so that has to be cleared. Then close all. So, this command is meant for closing any child window that has been opened. So, those figure window or any other windows like workspace window has been opened, then it has to be deliberately closed. So, these are the three basic command. In general, I advised you to write first in order to ensure that the environment is completely free from any old as well as previous junks, in order to make this particular simulation is completely free from everything. So, this is the first executable statement with respect to the modern development, that is loading the data set. So, here if you could see that the load is the command that is used to load the data set. Here the data name is iris data and this data is stored with the extension .m. So, it means that the data is available in any format, DAT format, .txt format, .csv file format or any other format, but it is very easier once we convert this into a .m format. Here you have to remember one thing, that if the data is very small enough, then it is very easier for us to convert it into .m format. Otherwise, there are specific commands are available to load the data that is in the specific format, .dat format or .csv or .xls. So, for various kind of format, .xlx format, .dat format, .csv format, for all kind of format specific MATLAB commands are available to load the data. So, in order to make it very simpler, let me start with this presentation as loading the data set in .m format. .m is format is the meant for MATLAB format, right. So, where can I get this data? Where can I get this iris data? So, for which you have to go to a UCI machine learning repository in the website. Let me open that. So, in a Google if you type UCI machine learning repository, it will lead to a page where you can find enormous amount of data sets using which you can do lot of work related to machine learning or data mining or whatever the artificial intelligence techniques are intended to do it. So, here if you could find that there are many popular data sets, and one particular data set that we are going to discuss in this presentation is iris data. So, let me click this iris data. If you click the iris data, it will give the various basic as well as the fundamental information about the iris data. Actually what is iris data is, so it is a flower, iris is a flower and it consists of 3 different categories of flower. So, let me show you that flower also. So, if you could see that in the image there are 3 kinds of flower, right. So, there are 3 varieties of flower. So, what are those varieties are? The varieties are iris setosa, iris virginica and iris versicolor. So, there are 3 categories of flower. So, our objective is to develop a back propagation neural network model that accepts the data and classifies the flower according to its category. So, if you could see that in this data set, the number of features are 4 features, number of instances are 50 instances. So, what are the 4 features? The 4 features are sepal length, sepal width, petal length, petal width. And how many instances are there? There are 150 instances. So, how these 150 instances come? So, 50 instances for one category of flower, 50 instances for another category and 50 instances for the last category. So, there are 150 instances and each 50 data corresponds to a particular category. So, how to download the data? The options are available in order to download the data and you can see the data and see the variables available in the data and everything you can see very visualize. See, if you could see here what are the variables available? Sepal length, sepal width, petal length, petal width. So, these are the 4 features. So, what is the type of that feature? The type of the features are continuous. It means the values are floating point values. And what is the last one? That is the output variable class label and it is utilized as a target variable and it is a categorical variable. It has the meaning of, see the iris plant, iris setosa, iris versicolor, iris virginica. There are 3 categories of flower as I said in the earlier discussion. So, that is all about the basic fundamental information about the data and now we go back to the MATLAB environment. Before going to the MATLAB environment, let me discuss about how the data is looking like. See, this data is looking like in a tabular form. See, the first column corresponds to this first column 6.3, 5.8, this first column corresponds to sepal length, this second column corresponds to sepal width, this third column corresponds to petal length and fourth column corresponds to petal width. So, these are the 4 fundamental information. If you could see in the flower information, see this is sepal, this is sepal, this green color component is going to be called sepal. So, it has various measurements and it has various values and all those values are recorded here 6.35, one flower sepal value is 6.3, another flower sepal value is 7.2, another flower sepal value is something 5 or 5.8 like that. So, this is sepal value. What is petal value? This purple color or the violet color sometimes may. So, these petal length and width are also recorded and it is displayed as a column value. So, these are the 4 values that you can be visualized recorded for a flower. And let me discuss about what is these 3 values are 100. So, this 100 represents a particular flower category. So, what are the 3 categories of flower? It is mentioned earlier. So, what are the 3 categories of flower? The 3 categories of flowers are sepal length, sepal width and petal length and petal width. So, there are 4 input variables and the 3 output categories are iris setosa, iris virginica and iris versicolor. So, this 100 corresponds to iris setosa, that is a one kind of flower, and let me for which how many instances are there? 50 instances are there, and next it corresponds to 010. In 010 category we have 50 flowers and it is iris virginica, and coming to the last category that is 001, that is iris versicolor. So, these are the 3 categories of flower. So, whenever you want to develop any MATLAB model development, you have to go to the UCI machine learning repository from you can find a lot of informations, and in that informations you can choose a popular data set that is of great interest to you in order to develop the code. So, this presentation will discuss about the BPN model development. The BPN model development will create its architecture, that is input layer, number of nodes in the input layer, output layer, number of nodes in the output layer, hidden layers and number of nodes in the hidden layer, and bytes and bias value, everything is set based on this data only. So, the data plays the vital role as I discussed in the earlier presentation. So, based on the iris data, everything is framed. So, the first step in the process of MATLAB model development is loading the data sets, loading the iris data set. So, how this .m file is coming? See that file that I opened in the notepad, which corresponds to so many columns. Let me discuss that once again. So, that is the file that you want to have it for your discussion. So, that first column corresponds to the sepal length, second column corresponds to sepal width, third column corresponds to petal length and petal width. So, these are the 4 information that is needed. So, when you load it into the MATLAB environment, so what you got is, see, this is the data, that notepad file is saved in the extension .m in order to load the data very easily in the MATLAB environment. Nowadays, apart from .m format, many formats are available. Once the data is loaded, the data is loaded in the IDE. What is the IDE? MATLAB Integrated Development Environment. That IDE only the data is loaded first. But we need to store the data into a variable, then only it can be accessed in the throughout the program. In order to assign the data into a variable, I used a variable called xy. So, xy designates the variable that is used to store the data. Now, after executing this command, so what is happened is a variable xy is created. In MATLAB, each variable is treated as a matrix. So, what is xy now? So, xy is a matrix. That xy matrix is created in the MATLAB environment, which holds the value iris data, So, what is the content of the iris data? The iris data contains 4 input column and 3 output column. The 4 output columns are looking like this: 6.5, 7.2, 3.8, 4.5. So, what is this 6.5 corresponds to? Measurement of a single flower whose sepal length is 6.5. Measurement of a single flower whose sepal width is 7.2. Measurement of a single flower whose petal length, petal width, accordingly you can take it. So, likewise, how many things are there? 150. Likewise, how many things are there? 150. The first 50 corresponds to setosa flower. The second 50 corresponds to versicolor. The third corresponds to virginica. Likewise, it goes. So, now you please tell what is the matrix size of xy according to the data. The data is available like this: 4 columns for input variable and 3 columns for output category. So, totally how many columns are there? Totally 7 columns. How many number of samples are there? 150 samples. So, the size of xy is 150 cross 7. So, xy is a variable created in a MATLAB environment, as MATLAB software is a software whose handling of the variable is in the form of matrix. So, xy is also a matrix, and that xy is holding the variable which has 7 columns. Out of that 7 columns, 4 columns corresponds to input and 3 columns corresponds to the output category. So, totally 7 columns are there, and how many number of records are there? 150 records, 50 records for each category, put together 150 records. So, 150 records means, so the size of the xy variable is 150 cross 7. Now, I want to divide the data into input as well as output. Now, the xy consists of whole input and output put together. Now, this command is a matrix manipulation command. I wish you to remember the presentation that dealt with matrix manipulation commands. So, xy is a matrix, which consists of inputs and outputs put together in a single matrix. Now, I want to divide that xy matrix into all rows. I want all rows. But how many columns? first 4 columns which corresponds to input variable. So, 1:4. If you take it and if you assign it to x, then it is the variable, that is a matrix X. Likewise, the last 3 columns corresponds to output, right. 5th column, 6th column, 7th column, like 1 0 0 sometimes, or 0 1 0 sometimes, or 0 0 1 sometimes. So, for this we have 50, for this we have 50, and for this we have 50. So, totally put together we have 150. So, we have created the y variable according to this command. So, this is the way in which the data is loaded, which consists of both input and output, and the input is separated from the output and it is stored in the corresponding variable. Now, the data separation has to be taken place. What is data separation? Separation of data into training and testing. In order for our convenience, I named the variable as x2 and y2, that signifies the testing variable, x1 and y1 that signifies the training variable. That means x1 is meant for, see in general what is x? X is meant for training, right. If it is x1, then it is training input. If it is y1, y is meant for output, right, that is training output. See, I likewise x2 is meant for testing input, y2 is meant for testing output. So, this is the naming convention that is followed here. So, from the input variable matrix X, and it has 150 rows, right. For each 2 I have taken a data in order to have a equal partition of the data, both for the input case as well as for the output case. So, this column, that is 1 to 150, I need to access the variable in how many gaps? With respect to 2. So, I have to access the data from 1 to 150 with the equal space of 2. That means data 1 is there, data 3 is there, data 5 is there, data 7 is there, likewise it goes. Accordingly, the corresponding output. So, the x2 and y2. Now, I have a simple logic. Wherever I have chosen a add number, in that add number I have made it as a empty matrix in order to hold that value. Now, what is this x contains? What is this y contains? This x2 contains 75 data, x2 contains 75 data, y2 also contains 75 data, the same corresponding input and output pair. So, now the matrix is emptied wherever the location we have taken the data and assigned it to the x2 variable. So, that location it is being emptied, and that location we have assigned the variable x1 and y1. See, x is assigned to x1 and y is assigned to y1. So, guys, now the data is separated in par with training and testing, and it is randomly separated with the step size of 2. So, now x1 corresponds to training input, y1 corresponds to training output, x2 corresponds to testing input, and y2 corresponds to testing output. So, this is the case. Now, it is the responsibility to decide on training and testing. So, this is pair x1 y1 pair is used for training, and this x2 y2 pair is used for testing. So, this x1 and y1 is used to train, this x2 is used to simulate. Based on the output we have to compare it with the y2, then only we have to produce a result. So, this is the idea. Next. Now, there is a most important step, that step is called data normalization. So, what is normalization? In general, while we are working with any data variable, the data variable values may range from 1 to 10 or 5 to 50, or maybe it goes to 1000 to 10,000. So, in what we could see in a data is the variables value, we can't get it in a predefined range, it may be of any range. When we use such kind of data as such, that is when we use the raw data as such with various ranges, what of the algorithm, that is the machine learning algorithm or soft computing algorithm or algorithm like neural network, what it will try to came to know from the values is, it will assume that the higher valued variables are a dominant variable that will suppress the lower dominant variable. So, it will give priority only to the higher valued variable, leaving behind the lower valued variable. Sometimes in the practical context, the values which is having smaller value will have a greater impact in order to perform the classification, particularly for medical diagnosis or any real time situations. So, we need to smoothen all the values according to a predefined range, that is called scaling, or it is otherwise popularly called by the name normalization. So, we have to normalize all the data variables into a predefined range. In order for that, we will be taking these two command, maximum of x1 and minimum of x1, and we are using this particular expression in order to do the normalization task. This normalization formula is already discussed in our previous presentation. A particular value is taken, x1 of I comma j, a particular value is taken. In that particular value, what is the minimum value, that has to be taken a difference, and that is the taken by the ratio of the maximum value minus the minimum value. So, this will give you the normalized value of x1. Now, you remember, like x1n we have y1n, we have to create y1n, and we have to create x2n, and we have to create y2n. Here you may ask a question, already x1 and y1 are already the values are 1 0 0 or 0 1 0 like that. So, no need for specific normalization formula application, just a naming convention or conversion is required, that is y1 is changed to y1n in order to say that the variable is normalized, simply an assignment statement. y2 is changed to y2n, so in order to say that the normalization. So, this is the programmer's logic. So, you may do like this, or you may have any other idea, you can do like that. But x1n and x2n are normalized value that is created from x1 according to this expression, likewise for x2n. So, this entire for loop is repeated for 2 times, one for x1, another one for x2. 2 times you have to repeat this set of segment, because those values are fractional values. What are those values? 6.2, 5.8, 4.9, 3.7 like that, the fractional values, because it is continuous variable, right. So, those values has to be normalized within a predefined range in order to avoid the dominance of higher valued variable to the lower valued variable. So, that is the purpose of doing this kind of normalization network creation. Now, our data is completely ready, right. Now, it is the time to look after the creation of the neural network. In order to create the neural network, we have to use a command called new ff, that means new feed forward neural network. So, that is the network that is created using the MATLAB command. In the latest version of MATLAB, this new ff command may be depreciated, but however you can use it also. So, this new ff command has the syntax like this. So, first you have to give the maximum and the minimum value of the entire data, that is a PR. Then you have to give the number of hidden layer n hid, number of output node n out, and the activation function in all the layers, and what is the tan sigmoidal activation function is between input layer and hidden layer, and pure line activation function is between hidden layer and the output layer, trained scaled conjugate gradient, gradient Levenberg model. So, these are all the algorithm. What is the error measure? We have mean square error measure. So, these are the complete things that you need to use for creating the network, and all the values are randomly created. So, we have initialized the random generator, and we have to initialize the web weights, that is the layer initialized. See, this is a randomly initialized weight values, 1,1 corresponds to input layer to hidden layer, right. So, for each layer you have to do it, and this is the bias initialization, and this is the bias initialization in the hidden layer. So, this is the thing that you. So, finally you have to init the net. So, after executing this init net, what we got is, we got 1 2 3 4. So, what is this 4 represent? This is for sepal length, this is for sepal width, this is for petal length, and this is for petal width. So, these are the 4 things we got. Now, how many hidden neuron is used? 4 hidden neurons. So, again 4 hidden neurons. 4 hidden. What are the output neurons? 3 output neurons. 3 output neurons. So, this is our. So, how the connections are? So, connection is from each. So, this is a massively parallelly connected architecture. Likewise here. So, this is the neural network we have created. So, here in the output what we got? Maybe we got 1 here, 0 0 here, maybe we got 0 1 0 here, or maybe we got 0 0 1 here. So, like this we got. So, if we got 1 0 0, it is setosa, it is versicolor, it is virginica 0 0. So, like this we have to get it. So, this init command will create a neural network like this. So, this is the way in which you have to create a neural network model using the MATLAB environment. Next, training. So, in order to initiate the training process, we need to initiate certain parameters like epochs, goal, and we need to set the calculation of the training error. So, everything else. So, in this particular code, the epoch has been set to 1200. So, net is the initial net variable, the training parameter in which epochs. Likewise, net training parameter goal 0.0. So, what is this epoch represent? This is the iteration, number of iteration we need to do this. So, you have to recall our design parameters of BPN model presentation in order to know what is epoch exactly. When a epoch is set to complete, when a complete set of data is fed into the model for making the process of creating the output, that is set to 1 epoch. Likewise, how many times you have to feed the network? 1200 times you have to teach the network model this 150 data. So, 150 data, that is to be taught how many times? 1200 times we have to teach the model. Up to what level? Up to what level? 0.01 is the goal. Goal is nothing but the error that we have been expected. So, actually the network is producing the output 5.5, right, but the actual is 5 point something, and the difference between this value is 5 point maybe 65, like this. The difference between these two should be within 0.01. Until that, the training process has to be carried out. So, that is called goal. It is one of the performance metric. Now, see, look at this command. This command is very important command, train command. Train. Inside the train, what we are giving? Net. So, this net is the initial net that is created, initial net, right, and this x1 n, y1 n. So, I already told that, right. X1 n is the training input, y1 is the training. Why this normalized? Because why this transpose is there? Because the net is created like that. See, net transpose tr, we need that. So, that is the training performance value, right. So, net is there, the training performance is there in the tr. So, we need to take a transpose. So, rows is converted into columns, and it has to be assigned here. So, the syntax is written like that. So, we in the training function we have given net x1 n dash y1 n dash. So, this is for calculating the performance. This is for maybe how much CPU time it is taking during the training. So, time, CPU time is the present CPU time t. So, t is the one which is already recorded for taking out the time. So, weights, bias. So, weights and bias between the first layers, weights and bias in the second layers. So, everything has to be updated according to the training performance. So, these are all the weight and bias updation. So, during the network training we should do all these tasks. So, what are the tasks we have been doing it? Create designing, setting the epoch, setting the goal, training, then the performance recording. So, finally testing. So, sim is the command that is used for simulating the network, that means testing the network. If you look at it, while testing we have been using the net. Now, this net is the trained net, that is from the initial net. This trained net is supplied with x2n, that is testing input. Testing input alone we are giving it. it is producing the output. What is the output produced by this? The small y is the output produced by the model. This small y, which is the output produced by the network, has been taken and it is used for creating the difference between the actual output. Now, the actual output as well as the simulated output has been made to calculate the difference between these two values, and this difference is nothing but error. And this error is being utilized to go in the backward direction, right, in order to update the weights and bias values. So, that is called back propagation network. So, if you want, the previous presentation is discussing about the back propagation training process as well as the testing process, right. So, this is the error. This error is finally given out as a mean square testing error. So, this is the way testing, and finally display the result. So, what are the major commands? New, ff, init, sim. These are the three major commands. New ff is for creation, init is for initialization, before the train for training, testing. So, these four commands you should remember that. So, this S of I is holding the simulated output, this A of I is having the actual output. Totally how many samples we have taken for testing? 75 samples we have taken for testing. So, for each S of I with corresponding to A of I, there is a comparison. If a match is there, if the simulated output matches with the actual output, then we have to increment a counter. That means one variable is set to classified correctly accordingly for all the 75 categories. And finally, we have to plot all those things in order to visualize what is the network output and what is the actual output, right. I hope now you come to a clear idea about how to implement the MATLAB code for a neural network model development. So, with this I come to the theory presentation about the neural network model development. The next presentation will be the MATLAB environment. So, how this code has been written in the MATLAB environment and how it is executed, how the output is visualized. So, those kind of stuff we can see in the next presentation. Thank you.